Hello, and today I'll be showing you how to do addition and subtraction in hexadecimal. The first thing that you should know is that addition and subtraction in hexadecimal is similar to regular decimal. So I'll just show you what that looks like first. Here, highlighted in yellow, this is the decimal version of this number. And this is the hexadecimal version of here. So let's just add them together right now. So a 0 and a 1 gets us a 1, and a 1 and a 1 gets us a 2. Normally in decimal you would read this as 21, but in hexadecimal you read this as 2 and 1. So I'll just write that here. And in their decimal forms, this would be 16 plus 17, which would be 33, like that. So I can prove this if we convert it. And I'm going to be using this method because that's faster to show if you have a calculator. If you're confused how we got these numbers, I suggest you go check out the other videos on how to convert decimal to hexadecimal and vice versa. Anyway, so 1 times 16 raised to 0 is just going to be 1. And then 16 times 2 is going to be 32. And if you add that up, you get 33. So this answer is correct. I'm just going to move this over here so we have some room to play with. So now we have 5 and a 9. These are both the same in hexadecimal and decimal because the hexadecimal notation uses numbers 0. I'm just not showing the 0, but there's a 0 here. It's from 0 to F, so that's 16 digits there. So a 5 and a 9 is 14 usually in regular decimal notation, but in hexadecimal our 14 is E right here. So we write E, and there's no real need to convert because it's right here. So that's the answer there. Now what if we have 1/8 and then add that to A? 1/8 in decimal is 24 and A in decimal is 10, so we would know that the answer for this is 34 in regular decimal. How do we show that in hexadecimal? So we'll just pretend that the A here is the 10. So that's 10 plus 8. We get an 18. But we can't just write 18 here and call it a day. That's not going to work. So what we do is we get our 18 and then we subtract it by 16. So 18 subtracted by 16 is a 2. And remember, we had an 18 here, so we're carrying a 1 here. So a 1 and a 1 make a 2. Now let's convert this. And as you can see, 2 plus 32 is equals to 34 to 10. And that's the same answer. I'll explain this more later, so I can show you the formula if you want. A quick note about hexadecimal addition and the rule that I showed earlier. We carry a 1 if the sum of the digits is greater than or equal to 16. That's because we don't have a way of representing 16 in hexadecimal. We only represent it in numbers of 0 to F, or 15, right? Which is 16 digits. So 1 to 15 here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Anyway, I'll show you what that looks like here with simpler examples. A, which is just 10, plus 5, which is just 5. So A plus 5 is 15. But again, 15 in hexadecimal is represented by an F. So we just write an F there. We don't need to do anything else. A plus 6 is just 10 plus 6, right? So 16. Remember, it's because we bring down the 1 after adding the 6 here. But we can't just do that here. We can't just do 16 like that. There's no way of representing 16 in hex, right? So we use the formula here to convert that, our number here, because we have a 1 carried there. We use this formula to convert that number into hex. So 16 is equals to 16 plus x. We get our x here by subtracting both sides by 16, which is just going to be 0. So our x here is going to be 0. And then we have a 1 here because we carried 1, since the sum of these digits is equal to 16. So let's just bring down the 1. So that's 10. And when we can convert that to show you that's true. So 0 times any number is just 0. 1 times 16 raised to 1 is just 16. As you can see, that's true, because 10 plus 6 is 16. What about a longer example? We have AA plus 6. AA is just 170, and 6 is just 6. So let's do that again. Again, we know that A is just 10. So 10 plus 6 is 16. So we use this formula again. So 16 is equals to 16 plus x. Subtracts both sides by 16, and we get a 0. So we know that the x here is 0. So we write a 0 there, and then we carry the 1 from earlier. Now, there's no digit here, right? There's nothing here that we can add a to. So usually you just bring the a down, right? But no, remember, we carried a 1 because the sum is equal to 16. And we know that a is equals to 10. So that's just going to be 10 plus 1, right? So 10 plus 1 is 11, but we can't just write 11 because we can represent 11 as b in hexadecimal. So we write b here. So we can convert this to show you that this is true. 0 times 16 raised to 0, b times 16 raised to 1. Remember, b is just equals to 11. So that's just going to be 0, and then b times 16, or 11 times 16, is going to be 176. And as you can see, this logic would hold true because 170 plus 6 is just 176. So, you know, so if we get a 0 as our x value, like so, right here, we write the 0, right? We write the 0, and then we carry the 1 to the next digits. So we carry the 1 here. We write the 0, and then we carry the 1 to the next digits here. And much like regular base 10 addition, we bring down the 1 if there's nothing else to add. So we brought down the 1 here because there's nothing else to add, so we get a 1, 0. Here's an example comprising only of the letters in hexadecimal. So, as earlier, I told you something about subtracting 16 from our answer to get our sum in hexadecimal form. I'll show you what that looks like. So much like regular addition, we just focus on the digits that are lined up together like this. So let's get C plus A. C is just 12, and our A is just 10. So that makes 22. But we can't just write 22 here and then carry a 2, because this is in hexadecimal. We can't just do that. So what we can do is we can use this formula here. So why is our sum in decimal? So we know the sum of 12 and 10 is 22. So 22 is equal to x plus 16. And we know that our x is the sum in hexadecimal. So what we can do is we can subtract both sides by 16. Right? Oh, that's a little confusing to write, but you know what that is anyway. So 16, right? And then we get 22, that's going to be 6. So our x is going to be 6. So we can write our 6 here. But remember, much like in normal addition, like if we had 18 plus 8, this would be 16. We would carry the number here to the next number, right? To the next digit, I mean. So much like that, we carry a 1 here on top of our D and B. So I'm just going to move that to the side. Actually, I'll use a different color too, so you guys can see it clearly, and I'll just leave that there. So our D and B. D is just 13, right? So that's going to be 13 plus 11, which is going to be 24. 24 is equal to x plus 16. And then 24 minus 16 is going to be 8. So we write 8 here. But remember, we have a carry. We carried a 1. So 8 plus 1 is 9. And then we add another carry because we added by 16. I guess I'll use orange here. And I'm going to delete this. So we have A plus D for their last number. We know that A is 10, and we know that D is 13. So that's 23. Again, 23 is equals to x plus 16. And then to get our hexadecimal format, we just subtract 23 by 16, which is going to be 7. So our x is equals to 7. But again, we know that we're carrying by 1. So that's going to be an 8. But remember, we have another carry 1 here, since we added a 16 from earlier, right? So that's going to be 1 here. So our answer is going to be 1896. And here is our decimal format. So if we add those together, we can check. 2780 and 3514. 9, 12, 6. So this is supposed to be our decimal answer. How do we convert our hexadecimal into decimal? So again, I'm just going to use this formula here. 0, 9 times 16 times 1, 8 times 16 times 2, and then 1 times 16 is to 3. So that's just going to be 6. 9 times 16 is going to be 144. 16 raised to 2 times 8 is going to be 2048. And 16 raised to 3 times 1 is going to be 4096. And then if you add all of these up, we get 6294. As you can see, that's the same answers over here. So that means our hexadecimal answer here is the same.